Hey, this is Stephen Ament. Welcome to my Exorcism.io series. In the previous episode, we worked on the luhn exercise, and we got all the tests passing. The code we wound up with was, this was our brute force code. This was sort of the first pass to get everything working. We dumbed it out, and we wound up with working code, but very ugly code. This is not something I would feel good about leaving in the code base or merging. This is always the approach that I take. I just want working code first. I want to separate in my mind the work of getting my test passing, getting everything working, and then the work of refactoring to get the code into a maintainable spot. It's equivalent to writing and then editing if you're a writer. When you're writing, it's in my mind the best practice to just get a draft on paper first and then to go back and edit it. To keep those as separate tasks. Those are sort of separate things going on in the brain. And also it's like if we try to refactor too early, or if we try to get a beautiful solution too early, sometimes we miss things, or we over optimize, or we come to the wrong refactoring first. But here, all of our tests are passing, and there is so much that we can do. And so I'm just going to kind of walk through here all the things that I see. I see a lot of things that we can change to make this better. So let's just dive right in here. And the first thing I see is everything lives inside of this class level method right now. Well, we've seen this pattern before where we have a class level method, and really that's sort of a convenience calling method that replaces code that looks like this. So remember, we implemented both of these cases in another exercise recently. And it's a shorthand way of doing this, without having to type that out every time. It's called a convenience method. Oh, what have I done? But also, Ruby is an object-oriented language. We have objects, and objects are collections of data and functionality. This is sort of just like a bare function. And what we want to do is we want to take advantage of the sort of thing that objects do well and make a luhn object, a well-formed luhn object that knows how to take an input string and return this answer valid. And so the very, very, very first thing we can do is just move this inside of code that looks like this. And so what's that going to be? Well, there's going to be a valid method here that we can simply paste that code into. That's not enough to get this to pass, though, because we need an initializer here that takes our input and saves it. That's also not enough to make it pass as is. We need to define an adder reader. And then that should get us back to green. I like to work in really small steps. I don't like to be away from green for very long. I like my tests to be passing when I'm refactoring sort of every step of the way. So I do very tiny changes. Okay, so what's the next thing we can deal with? All right, we can deal with this duplication of this G sub. I see we're doing it every time here. So we can actually just move it right here. There's no case in which we don't want to remove the spaces, and we don't really care about the spaces. We want to allow them, but we just want to get rid of them. So let's go ahead and get rid of it there. We want to get rid of it here. Whoa. and our code still passes. So let's see. So one thing I like to do just as a matter of habit, and this is really something you want in your production ready code that our tests are not requiring, but we want to make sure, we want to do the best that we can to make sure that what we've been given is the type that we expect it to be, or can be coerced to that type, but without checking, right? What we don't want to do is, is check if luhn number is a string or something like that. We don't want to do that kind of stuff. We want confident Ruby. So we want to use this convenience method, the string conversion method, to make an attempt to force whatever we've been given to a string, otherwise to throw an exception at that point. And so, as we've done elsewhere, we've never left this here in our initializer. We've given this a name. Normalize. And this can be a private method. There's no reason to expose it to outside of our class. And already we have more readable, more maintainable code here. So on initialization, we normalize our input and we save it to an instance variable, which is available through this adder reader. All right, well, what's the next thing we can do? Let's just keep stepping through. Valid here. We have these two initial validations happening. One, we're checking the length, that the length is less than or equal to 1, or I should say, we're ensuring that the length is not less than or equal to 1. Well, I don't like leaving these sort of checks over here. I like to name them so that it's super clear. It's very explicit what I'm doing, and I don't have to think about it when I come back in 6 months without the context I have now. So really, what's the case that I'm checking here? Well, I want to return false if it's too short. I guess, this doesn't have to be private. This might be something we want to check or be able to tell the outside world. So I'm just going to move it back here. And actually, I like to keep my methods in alphabetical order. So if it's too short, or in this case, what are we checking? So we are checking to see if there are any non-digit characters. So really, what we want to know is, are there any invalid characters? Which invalid characters means that there are non-digit characters in our string. Okay, so we're going to return false if it's too short. We're going to return false if there are invalid characters. And once we've checked those two things, we want to take, we got this ugly block of processing here, the output of which we want to know if it's evenly divisible by 10. So I just want to, I want this, what I really wish this code said was, so what do we want to call the output of that, all of that processing that all of this processing, maybe the luhn value or the luhn sum. I want to know if the luhn sum is evenly divisible by 10. So assuming we have something called luhn sum, this little expression here, luhn sum modulo 10 is equal to 0. This fairly explicitly means is evenly divisible by 10. So I don't see, this is not a case in which I would stick this in a method and give it a name. I would leave this as is right here. And so what would we do here? Let's just stick this whole thing into a method called luhn sum. Don't worry, we're going to do way more to this. So does that work? Yes. And so valid reads pretty much how I want it to read now. I'm going to return false if too short. I'm going to return false if there are invalid characters. Otherwise, I'm going to return the result of this. Asking the question, is luhn sum evenly divisible by 10? And yeah, so if luhn sum modulo 10 is equal to 0, the remainder dividing it by 10 is equal to 0. Yeah, I mean, that's literally what this means. And I think that's pretty clear. Okay. So now, we've moved some of this complexity here to luhn sum, and it's really horrible. So let's think about this. At the end of this process, what have we done? So we've taken our digits, or we've taken our number, we've split it, we've reversed it, taken every other digit and doubled it. And then we sum those. I think I want to call this doubled digits. Let's just, for the moment, let's do that, and let's look at it. Let's sit with it for a second. So what is the luhn sum? It's the sum of the doubled digits. So the doubled digits, the only thing I don't like about that is doubled digits has a specific meaning. It's not every digit doubled. It's the digits with the every other digit from the right doubled, and doubled in a special way. Let's go with it for now. And I think at this point, I'm going to jump in and deal with this bit here. No reason other than that's what I see. I've got this chunk of functionality going here. See, there's several things happening here, right? I've got all this stuff going here. I'm parsing my string into an array of characters. I'm reversing, each with indexing and mapping. I'm converting each one of these to a digit, and then I'm doubling here. Okay. Well, see, I just told you right here. I just gave you a clue as to what's something that's missing here, is that I'm doing this bit inside of this if block. I used a noun, or I used a verb. I said I'm doubling. Well, I don't see that word in here. I see two lines that are doing something. And so let's just go ahead and double digit. Double digit. And I think I'm going to have to explicitly return digit at the end here. So we're going to take digit, we're going to double it, we're going to subtract 9 if it's greater than 9, and we're going to return it. Okay, something is failing here. if index is odd, let's back up. Let's just back up and make sure we're in a happy spot here. Okay. Oh, I know what we did. All right, yeah. So we actually need to save this. Digit equals double digit. And in this kind of case where I've got my if statement here and I've got just one line inside of it, I'm gonna want to one line that. All right, so now I think I like how double reads here. And I think I like this line here where digit equals double digit if index is odd. I don't like this being here, but I think the way I'm going to deal with that is, you know, here I'm parsing out the digits. And then doing some stuff with it. So what I want is I want a digits. I want to give that a name. Digits. And so what I want digits to be is this. And actually I'm going to memoize this. Do you know that term, memoize, memoization? It's this pattern here where if, you know, this is not something that's going to change. So we don't want to do the work over and over and over again for the life of our instance. Our instance is initialized with a string. And so for the life of that instance, the value of digits is never going to change, but we might want to ask for digits multiple times. So you stick it in an instance variable and you use this or equals. So what or equals is going to do, it's going to return the value of the instance variable. But if that's nil because it hasn't been initialized yet, then it's going to do the work on the right and it's going to set it. So what we want to do here is we want to split. And then I'm going to go ahead and I'm going to return a new array. I'm going to convert each character. I'm going to convert each character to an integer so I can get rid of this here. Sorry, that's digits. And this is pretty close to done. I'm sitting here and looking at digits, and what's going through my head right now, I'm debating here. I'm asking myself if there are multiple things happening in such a way that I need to separate them. Digits is an array that I take from the string I've been given. I split it, and then I map it to integers. I think this is fine. What I might do, I don't like that because of the memoization. You know, I'm only calling it once. Tell you what, I'm going to skip the memoization for now. Well, I'm not going to do that because digits is an instance method, a public instance method, and legitimately so, right? Because we might want to ask for the digits. We might want to see what they are. Double, I think, probably does not belong to the to the surface area of our of our instance. Nobody outside is going to want to use that. Digits is doubled digits. I can see. Invalid characters, yes. The luhn sum, yes. We could just name this sum. What is the sum? Well, it's the sum of the doubled digits. So the sum of our luhn, so this is our luhn sum, right, is what this is. Luhn in this case being an instance of the luhn class. So yeah, I think luhn sum is redundant here. It's the sum. So let's just walk back from the top and just make sure that everything is clear, it's readable, that it's maintainable. There's not too much going on in one place. So our entry point into this is always this convenience method, valid. We don't see any instances of it being called any other way, at least in the test that we've been given. And so what valid does is it creates a new instance of a luhn, the luhn class, giving it the luhn number and calling valid. So let's just look at each of those. Initialize takes the luhn number, it normalizes it, and saves it to an instance variable, which is then accessible through this adder reader. So what does it mean to normalize a luhn number? Well, this private method makes sure that we have a string and it gets rid of all the spaces. Okay. That's pretty clear, pretty simple, straightforward. So what does valid mean? Well, valid will return false if it's too short. It will return false if we have invalid characters. Otherwise, it checks to make sure that the sum is evenly divisible by 10. That's pretty good. That's pretty clear. So what's the sum? Well, the sum is the sum of the doubled digits. What are our doubled digits? Well, we take the digits, we reverse them, and then we map over them with our index. We want the index. We map over them, and we double every odd index. We double that digit. Otherwise, we just return the digit itself. So what does doubling mean? We double the digit. Well, we double it, and we subtract 9 if the digit is greater than 9. All right, now that gets us back to digits. What are the digits? Well, digits, we have a memoized value here. So we take the luhn number, which is the normalized number that we've been given, that we're accessing through our adder reader. We're splitting it to give us an array of each character, and then we're mapping over that to get an array of integers by taking each character and calling to_i. And that is it. I think this looks good. This is maintainable. Each of these methods is doing something very specific. Nobody's doing too much work. It's a lot more readable than what we had at the beginning. It's a lot easier to understand, and we actually have an object that is behaving like an object. Yeah, I really don't know what else I would do. If there's something else that you see, go ahead and leave a comment below the video. But otherwise, I'm going to go ahead and submit this. And I think I'm going to call it done. And I'll move on to the next exercise.